but they simply could not match what was happening in the new Generation 3 small block, or the LS. The architecture was extremely strong. GM spent a ton of time on the cylinder heads because that's where you get most of your gain. The bottom end, you can make it strong, but basically all you have is an air pump, and the efficiency of that air pump is what matters. So the combustion chamber technology changed, the compression ratio increased, the cam profiles increased, the motors went roller on the cams and the rockers, and they reduced friction everywhere they could. And the bottom line was a 5.3 LS in the late 90s or early 2000s was putting out over 300 horsepower, probably closer to 325 horsepower. If you compare that with the old technology small block from the 90s, say a K motor, 5.7 liters, and it was putting out about 180 horsepower, the improvement was dramatic. And we've done a lot of conversions where we replaced the earlier truck motors with a Gen 3 LSs, and it was always a great success. The customers always loved the extra horsepower that they had. So the Gen 3 motors was really a massive improvement. However, they were still burdened by the 4-speed transmission. The Turbo 350 had been around since the 1960s. They added an overdrive just like everybody else. Ford came out with their AXOD, etc. But you were still pretty much slave to a valve body driven, old hydraulic controlled transmission. So the Gen 3s had the manual transmissions, they had the 4 speeds, and they didn't have at the time state-of-the-art technology like variable valve timing, active fuel management, or cylinder deactivation. That would have to wait for the Gen 4 engines. So when some of you guys call and say, hey, I got a 2002 LQ9 or LQ4 6-liter, I want to put in my JK, the reason we don't support that, one, most of the Gen 3s are not legal in a JK, you're not getting the 6-speed transmission, and you don't have those other technologies like VVT that really can help. So we don't support the Gen 3s in the JKs. Now the Gen 3s ran from the late 90s through the mid 2000s, and they were a huge success. They put them in all their SUVs. They did have the LS1, the 5.7 liter. They also had a 6 liter for their performance engines. They had manual transmissions. They had the whole gamut. But the next evolution came pretty quickly, and that was the Gen 4 engine. And the Gen 4 engine built on the strengths of the Gen 3 engine. One of the significant changes was they went from a 24 times crank sensor to a 58 times. Basically, it's a 60-tooth wheel with 2 teeth missing. What this did, combined with the cam sensor, or on the timing cover, there's teeth, they could more accurately control fuel and spark and misfire detection, because the more resolution the cam and the crank sensor have, the more accurate the computer can predict where it is in the firing cycle. So they can literally get down where that crankshaft is within degrees of the 360-degree crankshaft rotation or 720-degree firing cycle. This means we have extremely accurate fuel and spark control. Now you combine that with the power of the ECMs that were coming out at the time. The LS1A and B controllers were powertrain control modules, and they only had a few hundred kilobytes of calibration in them. And they were controlling both the engine and the transmission. Well, by the Gen 4 engine with VVT, active fuel management, so you can take your 6.2 liter engine and turn it into a 3.1 liter engine when under a light load and get the benefits of that smaller engine. This required a lot more processing power, and that really was the inhibitor years prior. If you look at the Cadillac 468 from the 1980s, they just didn't have the computing power to make that engine work. Ford had direct injection in the 1970s, but did not have the technology to put it in production. So the Gen 4s started to bring this all together. Variable valve timing, cylinder deactivation, higher compression, but what really sets the Gen 4 engines apart from the Gen 3 is they went to the 6L80 transmission. The 6L80 finally, after 40 years of the older design transmissions, took the small block into the modern era. The 6L80 was low friction, low heat, diverse gearing, 4-to-1 first gear. Compare that to a 2.8 or 3-to-1 in the earlier transmissions. This meant you could launch heavier vehicles out of the hole and still cruise at low RPM on the highway. So you got better economy, the engines ran cooler. The 6L80 really was a breakthrough, just like the Gen 3s were a breakthrough in the engine technology. The Gen 4s also went to a coefficient-based operating system. What this meant was, instead of just having tables that would look up a number and then adaptives that would modify those numbers, they actually multiplied coefficients, and a coefficient could be the map sensor, intake air temp sensor, vehicle speed, coolant temperature. By multiplying these numbers on the fly, you can get more accurate fuel and spark delivery than if you were just using a simple lookup table. And then we move into the Gen 5s. In around 2014, GM started to end of life most of the LS engines and go with the LT engines. The LTs, like the Gen 4s, introduced new technology to the American V8. And let me interject by saying GM could have gone to a small V6, which they did. They could have gone to 4 valves, which they did in some engines. But fortunate for us, they decided that the architecture of the small block Chevy engine from all those years ago, a V8 without overhead cams, an overhead valve engine, was bulletproof. These engines are simple, reliable, less costly to manufacture. If you take a V8 with 4-valve dual cams, the manufacturing cost is just massive. And it's pretty amazing if you look at what the Corvette's doing today with the LT against its counterparts like the Ferraris, running right up there with them with an engine that really has 50-year-old architecture. The Gen 5 introduced direct injection. Finally, direct injection became a reality. Direct injection's been around for a long time, but there were issues with direct injection, whether it was blow-by or the injector nozzles wearing out, the metals required for the direct injectors, the temperatures they ran at. GM got it sorted. GM spent millions of hours designing the LT heads. GM patented technology in the PCV, the positive crankcase ventilation, cam phasing. They went to continuous variable valve timing, which again is huge, because instead of having the cam parked or open, we can now phase that cam and control cylinder pressure much more accurately. And this helps a lot. So if you get on the throttle and you want to accelerate, instead of the transmission downshifting and revving the motor up, which may not be as efficient, the cam just might phase a little bit, give you that burst of power you need, and the transmission stays in the higher gear. And there's a lot more to it than that. I'm just scratching the surface. But basically, the direct injection combined with the continuous variable valve timing, then the cylinder deactivation, which has been around since the Gen 4, really has taken the LT to a new level. GM also realized there was double-digit improvements going from the 4-speed to the 6-speed. With the introduction of the 8 and the 10-speed transmissions now in the LT, it's again raising the bar. I really hope GM and Chrysler don't drop their V8s. I've heard rumors that the Hemi might go away because it's too inefficient. I have a customer we're supporting right now that purchased a 2007 LY6, which is a heavy-duty 6-liter truck motor, and then a 2010 6L80. That combination is technically not compatible. The TCM in that later model transmission will not work with the early model computer. There are some differences in the engine, like the map sensor, oil pressure sensor, that need to be upgraded to run it with a later model operating system, and we're going to talk about that. That way, if you have an LC9, an LMG, an LH8, an LH6, an L94, an LS3, an L99, there's a lot of them, you will know what combinations we support. As a side note, there's a lot of Holden engines manufactured in Australia that we also support. Holden mostly use the 6-liter, where we use the 6.2. They do have the HSV 6.2s like the LS3, but the L76, the L77, we can support them with some caveats. So we're going to take this JK to the mountain, and this does have a true LS3 in it. So there's no variable valve timing, there's no active fuel management. This engine wants premium gas. This is a true performance engine with the fewest amount of parts. And it runs great. There is no VVT. I think I'll end the video on this. With the VVT engines, GM lowered the compression, and the reason is when the cam phases, it raises cylinder pressure. So they have to have a lower static compression to deal with that. The LTs having continuous variable valve timing means that they can control the cylinder pressure better, and it's one of the main reasons they can run the higher compression that they do. But this LS3 is just a pure, honest, small block Chevy from 1955, except built the modern way. All aluminum construction, strong. It still has over 10-to-1 compression ratio, which is pretty amazing on pump gas, but when you consider the LTs are 11.5, that's even more amazing. We're going to hit the mountain with this LS3, and we have a lot of test drives coming up, guys, so stay tuned.